Let's talk a little bit about the history of the linear programming problem and algorithms to solve it. First of all, unlike least squares, there's no useful formula for the solution. Remember, in least squares, there were the normal equations, which just represented a square system of linear equations, and we learned the correspondence between the solution to the normal equations and the solution to the least squares problems. In this case, there's no such formula. But there are convergent, efficient algorithms that find the solution on any given instance of a linear program. The simplex method was invented by George Dantzig in 1949. It moves efficiently from vertex to vertex of the feasible polytope, always choosing the nearby vertex with the best minimum cost. Eventually, it always ends up at the vertex with the minimum cost. It works well in practice, but actually has bad theoretical properties. You can devise examples where the simplex method visits every single vertex before finally arriving at the optimal one. And the number of vertices as a function of problem dimension and number of constraints can be quite large. So from a theoretical standpoint, this is not acceptable. What's interesting though is, as I mentioned, it does work well in practice, and it's fairly simple to implement rudimentary versions of it. If we could devote one more module to this topic, you could implement a decent version of the simplex method as a homework problem. Maybe you'll pursue that in your later studies. There's also things called interior point methods. These were first proposed by Khachiyan in 1979. They were turned into practical algorithms by Karmakar from Bell Labs and now form a commercial product called Cplex. These algorithms approach the optimal point from the interior of the feasible polytope. They do not move from vertex to vertex. Newton's method, which we'll learn about in a few modules, plays a key role in these algorithms. Who are considered the founders of linear programming? Leonid Kantorovich was the first to formulate linear programming problems in 1939. George Dantzig, as I already mentioned, published the simplex method in 1947 to solve linear programming. And John von Neumann developed duality theory and game theory associated with linear programs. If you have time and interest, search these names on Wikipedia and read a little bit more about this rich history of this important problem. The theoretical milestone came from Khachiyan, who I've also mentioned. He proved in 1979 that linear programs can always be solved efficiently. Remember, Dantzig's simplex method, developed 32 years before that, worked well in practice, but theoretically was known to have bad complexity properties. It's known to behave very inefficiently on certain problems. Khachiyan, on the other hand, proved that linear programs can always be solved efficiently. What about software? Well, there's lots of free open source solvers available, and we're using one of those, as I've already described, from UCLA. There's also lots of not free commercial solvers available that are very powerful and can solve huge problems. The applications of linear programming are almost countless. Linear programming is used in scheduling, routing, pricing, layout, resource allocation, factory automation, parameter optimization, trade-off studies, and economic planning. It's also used in machine learning and artificial intelligence and cooperative control of robotics and other autonomous vehicles. A basic knowledge of linear programming and least squares, like you now have, provides an excellent background and a foundation to work in any of these or a lot of related areas.